So in last week's video, we talked about how Bitcoin transactions work, but that's only half the story. After you send a Bitcoin transaction to be verified by the network, the genius of the Bitcoin network continues. So in today's video, we're going to be talking about how Bitcoin mining works and why it's crucial to preserve the integrity of the Bitcoin network. So thank you for joining us on our 5th episode of A Walk Down Sat Street. In last week's video, we left off at the verification stage of the transactional process, where a Bitcoin user's digital signature is broadcast to the Bitcoin network to be verified by all of the computers running a full node. Now, computers that are running full nodes are what gives the Bitcoin network its processing power. These full nodes essentially act as a server for the decentralized Bitcoin network, and their main tasks include maintaining consensus across all participants and the verification of new transactions across the network. And additionally, they also store a full copy of the Bitcoin blockchain on their device. Now, a full node is a pretty broad definition of a computer operating on the Bitcoin network, and you can further categorize full nodes into different types of functions. And for the purpose of this video, we're mainly going to be focusing on mining nodes. Now, when Satoshi Nakamoto designed the Bitcoin network, they realized that if these nodes had to immediately record new transactions on the network, it would inevitably lead to disputes because different nodes would receive the transactions at different times. So Satoshi came up with a clever solution to this problem, in which all of the computers on the network would have to compete with one another in order to accurately record new transactions on the network. It's the participation in this competition that we all generally refer to as Bitcoin mining. Now, the way to win this competition is that computers on the network have to compile a list of transactions into what is generally referred to as blocks. Once the computers have compiled this list into blocks, they then have to run that block through a specialized mathematical equation known as a hash function, which spits out on the other end a unique 64-character digest. The computers are competing to find a block that, when ran through that specific hash function called the SHA-256, generates a unique 64-character digest with a specific number of zeros at the beginning, which looks something like this. Now, given the nature of the hash function, if every computer puts the same transactions into their block, they would all generate the exact same 64-character digest when running it through that specific hash function. So, in order to create a competition, the computers on the network have been tasked with adding a random number to the end of their block in order to generate a digest with a different number of zeros at the beginning of that 64-character digest. So, for example, if two computers competing on the network had two identical blocks that they were running through the function, and one used a 5 at the end of their block and another used a 10 at the end of their block, they would generate a digest with completely different number of zeros at the beginning. So the computers on the network have no idea what number is the right one to add to the end of their block, so the competition isn't based on skill, but rather it's based on luck. But the computers that have more computing power are inherently more likely to win this competition because they can try more variations in a shorter amount of time. Once a computer on the network finds the right digest, it then broadcasts that block out to the rest of the computers running full nodes to verify that indeed it found the digest with the right number of zeros at the beginning. Once this has been verified by the network, the list of transactions included in that block is added to the blockchain and now becomes part of the unchangeable Bitcoin blockchain. The computer that found the solution to this problem is then rewarded with a freshly minted set of Bitcoin, which we'll talk about a little bit more in depth in next week's video. Following this, the computers on the network will begin working on finding the next block, and any transactions that were missed in the previous block will be added to future ones. The Bitcoin software has been designed so that new blocks are added approximately every 10 minutes, and it does this by either increasing or decreasing the difficulty of finding the solution to the hash function. It can do this by either adding or subtracting the number of zeros required at the beginning of that 64-character digest. If the computers on the network are solving the problem too slowly, then the network is going to reduce the number of zeros required at the beginning of the digest. If they're finding the solution too quickly, then they'll increase the number of zeros at the beginning of that digest. So that is the process of Bitcoin mining. We hope that you enjoyed this video and learned something new, and we look forward to seeing you all in next week's video.